So we'll look at general prisms now. So we've looked at quite a few different types. So rectangular prism, trapezoidal prism, a cylinder, which could be considered sort of an idea of a circular prism. So the idea is that you just have to find the perimeter and area of the base shape and then apply that to the generalized formulas. So this is a general prism where we're not actually using necessarily direct formulas that we have available to us, but the idea is exactly the same. So we're going to find the lateral surface area and the total surface area of this three-dimensional shape. So noticing that it's not actually a shape, like we said, that you can go right to our formula sheet for. But the idea of prisms is that you can cut at any spot, and then the two bases are exactly the same. So looking at this one, my front base can be this entire shape. And then as I go throughout the length of the shape, at the back I get the exact same shape for my two bases. So the idea is that you always want to be thinking about what is that common face, or what is that common base that you actually have, and that would be that shape out front. So I'm going to redraw it over here. So again, just to sketch out what my common face looks like. And then I'm going to put my units down associated with it. So along the bottom I have 12 meters. 3 meters. This one doesn't exactly tell me, but it's going to be 3 meters along here too. This is 7 meters, so definitely not to scale. Along here is 3 meters. They said this one is 2 meters, 2 meters. And so the only one we don't really know is this one along here. But we do know that this length is 7, this is 3, so we've already got 10 accounted for. So this has to be 2 meters as well. So again, that's going to be our common face, so that's what we find our perimeter and our area for, and then we can plug that into our generalized prism formulas. So let's start with perimeter and area. So perimeter, we're just starting on one side and add them all up. So 12 plus 3 plus 3 plus 2 plus 7 plus 2 plus 2 plus 3. Or did I do the 3 at the start? So 3 plus 12 plus 3 plus 3 plus 2, 7, 2, and 2. So again, adding those up, you should end up getting 34 meters come out there. And then our area is a little bit trickier because we don't have an area formula for this particular shape. So I'm going to cut it into two different shapes and make it composite. So I'm going to look at this little rectangular and make that area 1, and I'm going to look at this rectangle and make this area 2. So the total area is going to be adding the two of those up. So this will be area 1 plus area 2, and each of those is a rectangle. So we know that the area of a rectangle would be our length 1 times our width 1 plus our length 2 times our width 2. So it's just looking at those two separately. So let's start with A1. So length would be 7 multiplied by 2. And our second one would be 3 times our 12. So multiplying those out, adding them together, I end up getting 50 meters squared coming up there. So now we know our perimeter of our base, area of our base. So now we can go back to the idea of it being a three-dimensional shape to find our lateral surface area, which would basically be this, that side, etc., all around the shape. And then our total surface area would be adding the two bases as well. So lateral surface area is our perimeter times the height of our prism. So in this case, our perimeter is 34 meters. And the height of our prism, or the length of our prism in this case, is the 1.5 meters. So meter by meter, we end up getting, when we plug that into our calculator, 51 square meters. TSA, generalized formula for a total surface area of a prism, is using your LSA and adding your two common base areas. So our LSA is 51 square meters plus 2 times our area, which we found to be 50. So 2 times 50 gives me 100, plus 51 gives me 151 meters squared for our total surface area. So again, it doesn't have to be a shape that we recognize. It doesn't always have to be exact same formulas. We can use our knowledge of perimeter and area and basically do it for any generalized prism that has a different kind of common face.